Hello, everyone. Welcome to Reversing an Exploit Development. I'm Dr. Phil Polstra, and I will be the instructor for this course. In this short video, I wanted to talk about this exciting class. So, we're going to start the class by looking at various reversing tools, standard things that people in the industry use in order to do reverse engineering. So, we'll start our discussion of debuggers. So there's a family of debuggers that people like to use on Windows, Linux, Android, and Mac OS X in order to find problems with applications. We will also look at a family of decompilers. A decompiler lets you take a compiled application and turn it back into C code. Once it's back into C code, you can look for some standard flaws in that code. We will also discuss Metasploit. Metasploit is a very popular tool for those of us in the information security industry. It is an exploitation framework. So it allows you to develop exploits, also to deliver them in a nice automated manner. We will also talk about applications called fuzzers. So a fuzzer is something that you use to send large quantities of somewhat random input into an application in order to try to get it to fail. From there, you can try to figure out if that flaw that caused the program to crash is exploitable or not. And there are two basic kinds of fuzzers. There are network-based fuzzers that send things over the network, which would be the focus of most reversers. And then there are file-based fuzzers as well. We'll talk quite a bit about assembly language. Assembly language is one step up from the native language of a computer. It's just one step up from machine code. And we will talk about 32 and 64-bit Windows assembly, 32 and 64-bit Linux assembly, Mac OS X, and we will talk about ARM assembly, which is a vastly different thing. Along the way, when we're discussing assembly, another thing that will come up very quickly is what we call a calling convention. How do different functions get called in our programs? And we will see their importance in developing exploits. We will talk about stack buffer overflows. These are some of the most common flaws that we find in applications. So we will talk about these on 32 and 64-bit Windows and Linux. We will also talk about them on Mac OS X. And we will talk about various methods of preventing problems with stack buffer overflow flaws, such as stack protectors, which are implemented by default in various operating systems, in particular Linux and Mac OS X. And we will talk about various exploit techniques for stack buffer overflow flaws. We will also briefly cover ARM-based stack buffer overflows. We will then turn our attention to heap buffer overflows. And again, we will cover the 32 and 64-bit Windows and Linux platforms. We will cover Mac OS X. We'll talk about the different exploit techniques, which will vary quite a bit between these various platforms. We will also briefly cover the ARM platform and how that's a little bit different. And then we'll move on to format string flaws. This is another fairly common flaw. Now, this flaw actually is not dependent on any given operating system. So we will look at this flaw and apply it to all of the operating systems and processors for this course. We will talk about various protections that are offered by each of these operating systems. In particular, Linux and the Mac platform offer some protections by default that are not there for the Windows users. We'll talk about the different exploit techniques, and we'll go through some very detailed examples and show you how you can exploit these flaws. We'll also cover some miscellaneous vulnerabilities, such as section overflows. So in addition to overflowing various buffers, you can also overflow various sections in your programs. So we'll talk about that. There is likely flaws in your operating system kernels that can be exploited. So we'll talk about finding those and exploiting them as well. We will also talk briefly about Android applications and how you might find some flaws in them and exploit them. And we will talk about web vulnerabilities, which fall into two general classes. You have site flaws, things that are problems with the website itself. It's been misconfigured or there's a problem with the web server, etc. And we will also talk about code flaws, an error on that specific site that the developer of that site created. We will also briefly talk about database vulnerabilities, and those normally come in various injections. And often this can be combined with web flaws. So you might have a website which uses a database that is subject to some injection flaws. And we'll talk about that. We will also talk about using automation. For example, we will talk about how you can leverage scripting to discover vulnerabilities. After you've decompiled something, you might be able to use a little scripting to help you. We will also talk about scripting exploits. We will talk in depth about creating shellcode. Shellcode is the payload. So once you've found a vulnerability and you've determined that you can exploit it, you want to deliver some code to be run on the victim machine. That's called shellcode. So we're going to talk in depth about developing shellcode for 32 and 64-bit Windows and Linux. And we will also briefly cover the ARM platform and Mac OS X. We will talk about Metasploit. Metasploit is a nice tool for exploit development and delivery. We will talk about how you can create a module in Metasploit from your exploit script. We will also talk about encoding your shellcode to avoid detection from antivirus and from intrusion detection systems. We will discuss using Metasploit to perform web exploits and Android exploits along the way. A little bit of Python scripting, a little bit of Perl scripting, even some shell scripting. And there will be various tips and techniques along the way. So I'm very excited to deliver this class to you, and I hope that you enjoy it and that you learn a lot. We will see you soon.